Quadrats for sampling herbaceous vegetation come in a variety of sizes and shapes. They're usually square, but can be rectangular or even circular in shape. The size of the quadrat should generally match the size of the plants being sampled. For example, 20 cm by 20 cm or 20 cm by 50 cm quadrats are appropriate for plants that are a few centimeters in any one dimension. For prairies, which often have somewhat larger plants, quadrats of 50 centimeters by 50 centimeters or 1 meter by 1 meter are often an appropriate size. Cover is one of several measures that can be used to estimate the relative abundance of plants. Various ecologists have used different definitions of cover. We will define cover as that area of ground obscured by the plant's biomass when viewed from above. Cover is typically measured as a percentage of the total quadrat area. Cover does not very well account for differences in height or overall biomass of plants, but nonetheless can be a useful relative measure of abundance. A side view shows the large differences in height of these plants. From above, their difference in biomass is less evident. Here's another example showing big bluestem in a mass of brome grass. To estimate the cover of a plant or a group of plants, visualize a line around the edge of the canopy, more or less connecting the tips of the leaves. If the canopy is sparse with many spaces between leaves, a line connecting the tips of the leaves will overestimate the cover. A better estimate can be obtained by constricting the boundary line so that leaf area outside the boundary balances the gaps in the canopy within the boundary. Cover estimates should include only plant material within the quadrat, regardless of whether the plant is rooted within or outside the quadrat. In this example for gray-headed coneflower, note how only material within the quadrat is included. The cover estimate for gray-headed coneflower will be the sum over all the plants of that species in the quadrat. Estimate the cover for each species in a quadrat independently of the other species, even if the species overlap. In some cases, this may result in a total cover value for the quadrat over all species of more than 100%. And, if there is some bare ground, total cover may be less than 100%. Here is an example of big bluestem and goldenrod overlapping in the quadrat. Note that the spatial pattern of plants does not affect the estimate of cover. Plots with 20% cover of plants in a random arrangement, a regular arrangement, or a clumped arrangement would all have the same percent cover value. To estimate percentage cover, one first needs to establish a mental image of what different amounts of cover would look like for a quadrat of a given size. For example, in a 1 meter by 1 meter quadrat, a 10 centimeter by 10 centimeter square constitutes 1% of the total area. For comparison, many people have hands about 10 centimeters in width. A 22.4 centimeter by 22.4 centimeter square is 5% of the total quadrat area. A sheet of letter-size paper would be just over 6%. A 31.6 centimeter by 31.6 centimeter square gives 10% of the quadrat area. There are many methods for estimating percentage cover. Here are 3 commonly used methods. They're often used in combination with one another. One method is to develop a mental image of how different amounts of cover appear. Here are examples of 5% cover, 10% cover, 20%, and so on. Here is an example for Plantago. We'll outline plants of that species in yellow. By comparison with the images of 10% and 20% cover, we can estimate the cover of Plantago to be about 15%. Another method of estimating percent cover is to determine a cover value for each plant or group of plants. Then add that value to the cumulative total. Here is an example of estimating the cover of Plantago using 1% increments with the cumulative total announced. 1, 2, 3, 4, 5, 6, 7, 7.5, 8, 8.5, 9, 10, 11, 12, 13, 14, 15, 15.5, 16. A third method of estimation is to visually join all the pieces into one block and then to estimate the percent cover of that block. By comparison with our visual images of 1%, 5%, and 10%, we can estimate the cover of the block to be about 15 to 20%. With all methods of estimating cover, remember that the precision of any one measurement usually is not very important. Greater accuracy is achieved by measuring more quadrats, not by increasing the precision of measurements within a quadrat.